In this project, we will learn how to control the brightness of an LED using a potentiometer. Essentially, by adjusting the value of the resistance with our potentiometer, we can make the LED brighter and dimmer. We will be using a process known as pulse width modulation to accomplish this, or PWM for short. This is a simple circuit, but it illustrates how we can take analog readings as input from external sensors and use this to control another part of our circuit. Let's take a look at the learning objectives for this project. By successfully completing this project, we will have mastered the following items. We will understand what is a potentiometer and how to connect a potentiometer in a circuit, how to take an analog reading using the Arduino, understanding pulse width modulation and how it works, and we'll be introduced to three new functions: the analog read, analog write, and map function. Very handy and useful in our electronics projects. If you are ready to begin, let's get this project started. Here are the parts that we will need: an Arduino Uno, our USB cable, a breadboard, a red LED or any color LED that you may have, a 220 ohm resistor, a 10 kilo ohm potentiometer, and connecting wires. Before we move on to our circuit diagram, let's talk a little about pulse width modulation, or PWM for short. If you look at the waveform for a voltage signal, we can essentially modify the duration of time that the signal is high. In the first signal, we make the voltage high, but only leave it high for 50% of the time, then we make it low. Overall, the combined effect of this waveform is that the voltage is high only for 50% of the time, and hence a 50% duty cycle. In our second waveform, we keep the voltage high for 75% of the time, and then drop it low only for 25% of the time. In our last waveform, the voltage is high only for 25% of the time and low for the remaining 75%. In terms of our LED, the longer the waveform is high, the brighter the LED appears. The LED is actually turning on and off, but this is actually so fast that the naked eye cannot see it switching on and off. Thus, with our waveform in the middle, the LED will appear brightest because it is actually on 75% of the time, while in the last waveform it will appear dimmer since it is only on 25% of the time. Let's take a look at the circuit diagram for our project. Essentially, we have an LED that's connected to pin 9 of the Arduino. There's also a 220 ohm resistor. We have seen this previously. And this is our 10 kilo ohm potentiometer. One connection of the potentiometer goes to ground. The other end of the potentiometer goes to 5 volts. So essentially, at any given time, 5 volts is going to be dropped across our potentiometer. We now take readings from the center pin. So there, it goes to analog pin A0 of the Arduino. As we adjust the potentiometer, the voltage changes at this point, and we can read that input analog voltage. When we get to the code, we'll see exactly how this is done. To get an understanding of why the voltage changes at the middle pin as we adjust the potentiometer, it helps to understand how a potentiometer works. When we adjust the dial of a potentiometer, we are actually changing the resistance between one end of the potentiometer and the center pin. Resistance is the opposition to the flow of an electric current. The more resistance we have in a circuit, the smaller the current will be for a given voltage applied to the circuit. On the diagram, we can see that the 3 pins on the right correspond to the 3 pins on our potentiometer. As you turn the potentiometer in one direction, we are increasing the resistance and moving closer towards 5 volts. If we take a reading from our A0 pin on the Arduino, we would get a higher value. As we move the potentiometer in the other direction, we are effectively reducing the resistance and moving the point at which we take the measurement closer to ground or 0 volts. Hence, our reading from the A0 pin will get smaller until it is 0 when the dial is turned all the way down. When the potentiometer is about in the middle, as it's depicted here on the diagram, 2.5 volts will be the voltage that is at the center pin. We will get an analog reading in the middle of the range to reflect this. We will clarify how we take the readings and the specific analog values that are involved when we examine the code in more detail later on. Hopefully, this illustrates how our potentiometer works and how resistance changes lead to our corresponding voltage measurement changes. Okay, let's wire up our circuit. First, we're going to connect our LED. There needs to be a 220 ohm resistor from our LED that goes to ground. I'll connect that to the ground rail. Then I'll make the connection from ground to ground on the Arduino. The other end of the LED goes to pin 9. And now we're going to connect our potentiometer. Let's take a look at this potentiometer. As it's seen in the circuit diagram, there are 3 pins. The voltage measurement is going to occur at the center pin. So essentially, 5 volts is going to be applied to one pin of the potentiometer and the other end is going to be grounded. As we adjust and turn the potentiometer, we would record the voltage change at this pin here in the middle. That's what we'll use to determine the brightness of our LED. And we would take an input reading at this center pin and pulse width modulate our output signal accordingly to change the brightness of our LED. So we'll get this guy in the circuit. Okay, one end of our potentiometer goes to ground. So I'll make that connection. The middle pin goes to our analog 0 pin on our Arduino. And finally, the other end of the potentiometer, the 3rd pin, goes to 5 volts. So I'll make that connection here to 5 volts. Okay, that concludes the wiring of our circuit. Let's go ahead and upload the code. Alright, let's test out our circuit. As you can see, as I turn the potentiometer, the LED gets brighter and brighter. This is all the way to one end. And as I decrease it, it gets dimmer until it finally goes out. So again, we're taking that reading from the center pin and we are generating a pulse width modulated signal which affects the brightness of the LED. The longer the waveform is high, the brighter the LED is. At this end of the potentiometer, it is almost always high. That is why the LED is brightest. And as I reduce it towards the end, here the LED appears dim because it is off for most of the duty cycle. Let's take a look at the code to understand how we take those measurements and how we adjust the brightness of the LED. At the beginning, we do our initial setup and configuration. We define the LED pin as 9, it's connected to pin 9 on the Arduino, and the center potentiometer pin is connected to pin A0. On the left-hand side of the Arduino, the A0 to A4 pins are where we can take the analog readings, and there are certain pins on the right, digital pins on the right-hand side of the Arduino that are able to generate pulse width modulated signals. They have a tilde sign next to them. In our setup function, we set the pin mode of our LED as an output. That way we can write to that pin. And our loop function is fairly straightforward. What we do is initially we take an input reading, and here is where we use the analog read function. So we take an analog read function of our potentiometer pin, and that would give us a value that's in a range from 0 to 1023. Once we get that reading, we pass that as an input to the map function, which maps that 0 to 1023 range to a 0 to 255 range. And that 0 to 255 range is the range that we could do an analog write out to. So you can think of it as whatever reading we get at the center pin will have a value between 0 and 1023, but we want to get the equivalent of what that fraction or that ratio is of a value between 0 and 255. Because when we use the analog write function, the only values that we can specify are in the range 0 to 255. So we're performing a scaling, if you will, to convert that fraction or that reading that we get to an equivalent reading of between 0 and 255. Then we do an analog write function to the LED pin, passing in that scaled value that we just calculated. This will generate a pulse width modulated signal. If you send in 255, the waveform will be high, always high, and accordingly, if you send in a 0 as the reading, it will always be low. Then we have a small 10 millisecond delay between each analog write, and we just continue looping over this. To get some documentation on the analog read, analog write, and map function, let's do a Google analog write, and it will take you to the Arduino documentation here. As you can see, analog write takes two parameters. One is a pin, which is a pin that we need to write to, and the value. And of course, as I mentioned, the value lies anywhere between 0, which is always off, to 255, which is always on. For the analog read function, we can do a quick Google for that as well. The only input to that function is the pin, and as I mentioned, it returns a value that's in the range from 0 to 1023. So it takes that voltage reading in and returns this equivalent value. When we get that value, of course, we want to map it to that 0 to 255 range. So the map function becomes extremely convenient and handy. So we can Google that as well. If we take a look at the map function, as you can see, it takes 5 input parameters. The first parameter is the value you're trying to map. Then there's a from low, from high. That's the initial range that your input reading could be. And then what we're mapping it to, the too low value, the lower end of the spectrum, and the too high value to the highest end of the spectrum. So there's also a sample down here, an example. Here, similar to our program, there's an analog read of pin 0, and then we want to map that reading, whatever we obtained, to, and here's the from low, it's going to be between 0 and 1023, and we want to map that to some value from between 0 to 255. When we get that value, similar to what we're doing, they're doing an analog write to the particular pin and passing in the value. So hopefully, that clarifies those functions, and also to get the all the functions in Arduino, you can go to this link here, and you are able to click on any of the functions and get the pertinent documentation to them. Post that link in the resources for you, but here you can get to the documentation as for all the functions. A quick way to get to it though is just to Google it, as you can see, and typically the first link is the link to the appropriate function. That completes the code review for our circuit. To summarize, in this project you learned how the brightness of an LED can be controlled with a potentiometer. You were also introduced to the concept of pulse width modulation and how it works. Now you should be familiar with a few more Arduino functions. These include the analog read and analog write for taking analog readings and creating PWM output signals. And you can also apply the map function to convert values that occur in a range to a predefined output scale. It was a simple project, but we have mastered a lot of new concepts. We are picking up a lot of momentum here, and let's move on to our next project.